Hi, you are welcome to this class on integration. In this class, we're going to define integration. We look at types of integration, then integration calculation. These are what we are going to calculate today. For linear polynomial, we're going to look at all these: quadratic polynomial, cubic polynomial, higher degree polynomial. Okay? We are also going to look at all these questions. Then we look at radical or root function. That is the integration of all these questions, as you can see on the board. Now, what is integration? Integration is a way of adding up things that change continuously. If you want to add up things, okay, adding up things, this is what a layman definition: adding up things that change continuously. Imagine this is an apple, okay, which you have cut into a lot of pieces, infinitesimal pieces. You scatter it. Now you are adding them together. You are packing them together to know the total sum of this apple. Now, currently, the apple are all scattered like this, pieces of apple everywhere. Now you are adding them together. The process of adding them together, professionally, we say it is an operation used to determine the accumulation of quantity. If you want to determine the accumulation of quantity, integration is the operation we use for that, okay? We are talking about, say, area under a curve, okay? Say, for instance, this is S and Y axis. Say you have this now. You want to calculate this area under this curve. And this curve is a function, represents a function. You want to calculate the area under this. You can use integration to do this. What you are doing with integration now, you are trying to add up each of the pieces that make up this area under the curve, okay? All these pieces. They are very close, or very, very close, very, very close. Small, small, infinitesimal pieces. You are what? Piling together. We are talking about volumes and other calculation you might want to do with what? Integration. So generally, integration is the opposite of differentiation. So in calculus, you differentiate. If you want to come back to the original function, for instance, you are given y equals to 2x, you are asked to differentiate this. You get an answer. The answer you get, you can work it backward to this original question. So the answer, the final solution after integration, is called integral. Okay? So the final solution is called what? Integral. I'm just trying to define the terms for you to understand. So integration, that process you are using for integration, is the opposite of differentiation. When you arrive at the answer of integration, whatever answer you have is called what? The integral. Called integral. Okay? You can apply it in physics, in economics, in engineering, in many fields. You will see a lot of application of what? Integration. You can categorize integration into two parts. Two categories of integration. We have the indefinite integral and definite integral. As you can see, this is indefinite, something that has no end. Meaning, this one does not have what? Specific limit. No specific limit. No limit. You are going to see everything in this channel. If you have not subscribed, please subscribe. Because we cannot actually pin a limit to it, when you solve this type of question, you must have C to it. That's what we are going to look at today. That is the indefinite integral. Later in another video, we're going to look at definite integral. So this one has upper and lower limit. So for instance, you want to calculate this, and you can get the upper and lower limit. To use this limit to calculate the actual area, you are very sure of what you are doing. We are going to see instances of this. But put at the back of your mind, we have two types. That is the indefinite integral, which you cannot say it starts from here and hence here. And the definite integral, which you can say this is the beginning, this is the end. Okay? Now, generally, let me come back here. Generally, if you are given, say, y is equals to s raised to power n, then you are asked to find the y, the x. We have started calculation now. You do bring n here and reduce this one by 1. That is all. Okay? For instance, you are given y as equals to s raised to power 2 plus, say, x. You are asked to find the y over the x. You bring 2 down, you reduce this 2 by 1. You reduce it by 1. Remember, when something stands like this, it means there is 1 here. So we bring the 1 down, we reduce this one by 1 again. Just the way we reduce this one by 1. We bring you down, we reduce by 1, we bring you down, we reduce by 1. That is differentiation now. Differentiation. Now, this is equals to 2s raised to power 1, 1s raised to power 0. So this is 2x. This is 1 times 1. Anything raised to power 0 is 1. So 2x plus 1. So you can see, this is a constant. Now, if you are given to integrate this now, we are asking you to go back to where we are coming from. But most of the time, you might not be given this type of question. You'll be given, for instance, to integrate this. This is the y, the s, or something. You are asked to integrate this. To integrate this means go back to the original function. And the original function is this. That is this. This is the original function. Okay? So now, to integrate this, we say like this. Then we say 2x dx. Remember, you are not asked to integrate everything now. You are asked to integrate only 2x. All you need to do is to go back to where you are coming from. What brought you here? You were removing and bring it down. You brought down and removed. Now, we are going to do the opposite now. For this one, because we remove from here, this time, we are going to add 1. Remember, 1 is here already because there's nothing there, right? 1 is there. So we are going to add 1 to 1 that is already here. Before we are removing, now we are adding. Then, whatever you get from here, remember 2 is still here, you bring it down. That is this plus this, you bring it down. At the end of the day, now you are having, you are having 2x raised to power 2 over 2. This and this will cancel. S raised to power 2. Now, it's not finished. You will see that we have something here originally. But this one is not giving us, the final answer. We are not achieving where we are coming from because something is missing. How do we represent this that is missing? Many things can be missing because it is indefinite integral. We don't really know what is missing because we cannot pinpoint that this is the beginning and the end. Because of that, we must always add plus c. Plus c. This plus c constant is representing whatever that is missing. Whatever we are not sure of. Okay? I just want to let you know where this one is coming from. Okay? But if it was definite integral, which we are going to look at in another video, we don't need to put c because that one will give you limit. We tell you that what? It starts from, say, 0 to 2. To give you the limit. When you see this now, no need to put c. But because nothing was given to us here, we must put c because it is indefinite. We cannot get the beginning or the end of this. That is the purpose of the c, to help us represent what we think is missing. Now, the general formula, you do s raised to power n dx. If you are asked to integrate this, all you need to do, You simply say s n plus 1 over n plus 1. Whatever you get here, you bring it down. Remember, there's something here. There's something here. Okay? But what is missing now? Don't forget it. So you can say y is equals to this. The y ds is equals to what is inside. The y ds gave us this. We are now taking it back to y. We differentiated the y dx that brought us here. Now we are going back to where we are coming from. Where we are coming from is y equals to, that is the function, the original function. Integration helps us to go back, the opposite of differentiation. Okay? I have said this. What if you have something like this now? Say a s n dx. Now we have a value other than 1. The same thing. Simply do a f n plus 1 over n plus 1. Don't forget plus c. Hope you understand this. With the knowledge of this now, let's go and tackle each question I showed you before. Let's start with this linear polynomial. The first one, which we are going to do, we are asked to integrate this. You are given this to find the integral. You can be asked, what is the integral of x? You can be told, what is the integral of s? What is the integral of 3x? What is the integral of 4x raised to power 2? Or integrate x, integrate this, integrate that. So anyway it comes. For this one now, the answer is simply what? X, whatever that is here, which is 1, plus 1 over this plus this, plus c, which is x 2 over 2 plus c. So this is the answer for this first one. Okay? What about the second one? Now I'm not going to show you all this breakdown anymore. Let's see. For this one now, we simply do 3x 1 plus 1, that is 2 over 2, which you can write as 3 over 2, remember, plus c plus c. Okay? Very easy. Now, this one, for this, we can bring it out like this by saying 5x dx minus, we brought this one closer, then dx. Working on this now is 5s raised to power 2 over 2 minus 8x. Where am I getting x? That is what? The integration of constant. Let me show you. Before we come back there, let's look at this. Say you have this now, 8 dx or 4 ds, 1 dx. You can write this as 8s raised to power 0, because we want s, because this dx, s must come in. And to make s to be here without changing the question, we say s raised to power 0, because anything raised to power 0 is t1. So therefore, you agree with me for this now. We are still simply say 8 times 1 dx, which is 8 dx. So we have not changed anything. Now, to work on this now is 8s 0 plus 1. Whatever that comes out from here, we say over that. That is 0 plus 1 plus c. And you agree with me now, this is 8, 1, 1 plus c. Any 3 raised to power 1 is still the same t. You agree with me, this is 8x plus c. Okay? So whenever you see something without x, just put x. So for this we are working on before, we just put x, we now put plus c. Okay? This is the integral of this. Now we are through with linear polynomial. What if you are given s raised to power 2? The same thing. For s raised to power 2, let's come here. S raised to the power 2 dx. So this simply means what? S 2 plus 1 over 3 plus C. Remember, this is 3. S raised to the power 3 over 3 plus C, which is 1 over 3 S raised to the power 3 plus C. So I don't actually need to waste my time with all this. When you see this, simply do S raised to the power 3 over 3 plus C. Okay? Very easy and direct. Now, the second one says 4s raised to the power 2. 4s raised to the power 2. 4s raised to the power 2. Again, 4s raised to the power 3 over 3 plus C, which you can write as 4 over 3 s raised to the power 3 plus C. Let's now look at this. I want to solve it here. That is 2s raised to the power 2 plus 3x minus 1 dx. Okay? We are asked to work on this. Now, without even writing this, we can come out straight by saying 2s raised to the power 3 over 3 plus 3s raised to the power 2 over 2 minus x plus C. Finish. If you want to write it fine, can I say 2 over 3 s raised to the power 3 plus 3 over 2 s raised to the power 2 minus x plus C. I've actually explained the reason for this. When you see constant, just change it to x. A number without x, just put x here. That is now 1x now. Then plus C. Okay? That is that. Very easy. Very easy. Now, let's come. We are coming for this one later. We are through with all this. Okay? We are through with these ones. Now let's go for this cubic polynomial. For this cubic polynomial, let's work it here. That is this dx. Very easy. S raised to the power 4 over the 4 plus C. No issue. Straightforward. This one, can you bring the answer here? Don't need to rewrite this. Okay, let's rewrite it. X 2s raised to the power 3 dx. The integration of this is 2s raised to the power 4 over 4 plus C. Very easy. For this one, that is x raised to the power 3 minus 6x raised to the power 2 plus 2x plus x plus 8 dx. This one too, very easy. S raised to the power 4 over 4 minus 6s raised to the power 3 over 3 plus 2s raised to the power 2 over 2 plus 8x, okay, plus C. Very easy. You can simplify this further. You agree with me? To divide this is going to have 2. To divide is going to have 1. Very easy. Indefinite integral. So, as you can see, we are also through with everything here. Now, we are also through with this cubic. Let's look at this higher one. The same way, the same process. This one, to integrate this, the same thing, s raised to the power 5 over 5 plus C. This one, let's work it here. Let us not write it out. Okay, let's write it out. That is 3s raised to the power 5 minus s raised to power 4 plus s raised to power 2 minus 7x plus 10 dx. This one, straightforward. 3s raised to power 6 over 6 minus s raised to power 5 over 5 s raised to power 3 over 3 minus 7s raised to power 2 over 2 plus 10x plus c. You can see here, just add 1, add 1, add 1, add 1, put s. If you want to simplify for that, it's 1 over 2 s raised to power 6 minus 1 over 5 s raised to power 5 1 over 3 s raised to power 3 7 over 2 s raised to power 2 10s plus c. Very straightforward. Straightforward. Okay? You can see integration is simple. All of them very easy. Okay, now let's continue. I want us to now solve this. This one here. That is 1 over s raised to power 3. 1 over s raised to power 3. Let's come here. Now you have to remember your indices, your exponential. That is, this simply means s raised to power minus 3 dx. Remember, when it is 1 over, it means raised to power minus. So we are simplifying this now. Now you can do minus 3 plus 1 over minus 3 plus 1 plus c. This is minus 2 over minus 2 plus c. You can leave it like this, or if you want to show your mathematical prowess, you can go back to where you are coming from. This one means over all over minus 2 plus c. For some people that have forgotten basic mathematics, remember this is the numerator. Me divide by minus 2 plus c. What is the meaning of divide? Divide means this over 1 now. I shouldn't do this, but just for people that will say, how did you get that? Minus 2 s raised to power 2 plus c. You can write as minus. You understand? So you can see, we first of all add 1. Minus 3 plus 1 is minus 2, minus 2. We return this back to this form. This is the denominator, which means this divide by this and over 1. We turn it to times, then we turn it upside down. That is, we reverse it. Then we multiply this to have 1, we multiply this to have this, plus c. So you can see the final answer is this. Okay? Hope you understand this. So this is the final answer of this integration. This one gives birth to this. That is 1 over s raised to power 3. Okay, let's still go back. Now, I need to wipe part of this board because of space to work on this. Okay, let's wipe this. Let's work on this. That is the integration of 2 this one, first of all, we need to work on the numerator. If you work on this now, it means what you can multiply together to get this. You have this. You agree with me? For this one is 1 and 2. 1 and 2. So you can write this one as just normal quadratic equation. I shouldn't do this. I'm still doing it because of some people. So now you can say this is simply x plus 2s plus 1. Let's just jump a step. This and this will cancel. That is s plus 2. Let's wipe this. That is s plus 2. So now we have s plus 2 dx, which you can do like this. Dx dx. For this and for this, s and 2. This one will give us s2 over 2 plus 2x plus c. That is the answer. Okay? Check it very well. Straightforward. Very easy. Not difficult. See, integration is simple. Very simple. Now, I want us to work on this last one here. I am going to simply wipe here. Let's create a space. This one is, we have to expand this. 2 times 2 is 4. S raised to the power 3 minus 6s raised to the power 2 plus 8x dx. Now we solve this now. Each of them, this is 4s raised to the power 4 over 4 minus 6s raised to the power 3 over 3 plus 8s raised to the power 2 over 2 plus c. Can work on this now. This and this we cancel to have this is 2s raised to the power 3. Then this one is 4s raised to the power 2 plus c. This 2 is straightforward. So we have cleared all this, cleared all this, cleared this, cleared this, cleared this. This one now. Okay, now this 1 minus x over s raised to the power 3 dx. We have to work on this individually. That is 1 over s raised to the power 3 minus s over s raised to the power 3 dx. Okay? You agree with me that this is 1 over s raised to the power 3. Can bring this one here, dx, minus these two we cancel. You have 1 over s raised to the power 2 dx. Okay? Just divide. We separate now. We separate the two. Next is, because of some people, let's just break this down. Simple indices. Now you can add now. That is, you can bring in s minus 2 over minus 2 by adding plus 1 here. Minus 3 plus 1 is minus 2. Okay? This one is minus 1 over minus 1 plus c. Can I work on it? That is minus 1 over 2 s raised to the power minus 2. This and this will cancel to be plus. That is plus. This will give us 1 over x plus c. Can also work on this further. 1 over 2 times 1 over s raised to the power 2. This is minus 1 over 2s raised to the power 2 plus 1 over x plus c. So you can see it's very straightforward, very easy. You understand it? From here, first of all, this divided by this divided by this. Then we separate these two. Once we separate, we take it back to exponential form. Then we integrate. Then we simplify. Okay? So, as I said, don't forget to put the constant. You can put k, and all this one you are seeing, they are cap letter C. Okay? So we have cleared everything here now. What is remaining now is for radicals. Radicals. For radicals, let's do the square root of x. Let me come here. Square root of x. Go back to indices form. What is the meaning of square root? It means raised to the power 1 over 2. So if you add 1 to 1 over 2, what do you have? You have 3 over 2. That is 1 plus, that is 1 over 2 plus 1. You agree with me? Is 3 over 2. Okay? So very direct. 3 over 2 over 3 over 2 plus c. Okay? Plus c. Can I leave it like this? If you want to simplify, you simplify. Let us not waste our time. Simplification is not part of this class. So now, it depends on your exam. If it's option, if you can't see this as option, simplify further, I check the options. Okay, now let's go for the second one. That is square root of s, 1 plus s. Square root of s, square root of x, 1 plus x dx. To integrate this, we must expand this first. Square root of s plus s square root of x dx. Okay, let's work on this further. If I want to bring this one inside this square root, what do? I can do like this. Square root of x raised to power 2, square root of x. Do you understand the logic? This s, I want to push it inside the square root. I have to bring in square and square root, because this square root and square will cancel themselves, s will still remain. Now I can work this to be s raised to power 3 dx, because this time, because they are now both inside square root, I can now multiply them. That is s raised to power 3. What is this? This simply means s raised to power 1 over 2 dx. This simply means s raised to power 3 over 2. Square root is over 2, 3 is still here. Then we work on this now. We had 1 to 1 over 2 to have what? 3 over 2. That is s 3 over 2 over 3 over 2. Plus, we had 1 to this 2. That is 3 over 2 plus 1 over this. That is 5 over 2. Okay? Here, this is x. 5 over 2 over 5 over 2 plus c. Okay? Divide by 3 over 2 plus divide by 5 over 2 plus c. Just to show you, this is 3 over 2 times 2 over 3. This is 2 over 5. Then we bring this out to have 2 over 3, 3 over 2, 2 over 5. All about integration, just to be careful when you are doing all this. You know it is simple, but little mistakes. If you see any mistakes, it's because of carelessness, not because you don't know it. Put that at the back of your mind. Okay, so this is the answer. Okay, so now we are okay with this, okay with this. Now let's come for this now. Raised to power 1 over 3. That we can solve here. That is dx. That is, we simply say s 4 over 3, 4 over 3 plus c. Okay, this one you can simply say 3 over 4 s 4 over 3 plus c. That is for this. Very straightforward. Now let's go for the final one. Raised to power 1 over 4, 1 plus x. Let's wipe these guys. Okay? 1 over 4, 1 plus x. Okay? Now, we expand. Learn to expand. This will still give us the same thing. S multiplied by 1 over 4. Okay? Remember, this is raised to power 1. We are going to apply indices now. 1 over 4 plus, this is 1 plus this. As far as indices is concerned, 1 plus 1 over 4. 4 plus 1 equals to 5 over 4. 5 over 4, that is s here is 5 over 4 dx. Okay? Now, we can separate these two by say 1 over 4 dx. dx. Okay? Now, we add 1 to 1 over 4. If you add 1 to 1 over 4, you are going to have 5 over 4. So that is x now, 5 over 4 over 5 over 4 plus, for this one, I'm going to have 9 over 4. Okay? So now, you can say 4 over 5 plus 4 over 9 plus C. Okay? Very easy, right? We expand. This is still the same thing. If you add 1 plus this, because this is what? Indices. You take the base, you add what? The exponent or the index. That will result to this. We separate the two. We work this one separately. We work this one separately. This is the final answer. So you can see integration is easy.